Hi, this is a video for advanced topics in algebra. This is the first of a couple of different linear programming worksheets for homework. Remember, a system of linear equations in standard form? Linear inequalities in standard form. It's an inequality because there's that inequality system there, symbol there. It's a system because we have these curly braces here. But where do the equations come from? We've got some real-world situations to examine where we're going to find one or more equations in standard form. The reason we've been doing these in standard form is because the equations are a lot easier to make from a problem situation if you're using standard form. That's why we've been graphing them using the intercept method. So, Jess has made a commitment to exercise in order to lose weight and improve her overall fitness. Jess would like to burn at least, please notice that this says at least right here. That's going to tell us what inequality symbol to use. Jess would like to burn at least 2,000 calories per week through exercise, but she wants to schedule at most 5 hours of exercise each week. These two conditions here, or limits, are known as constraints. That word's going to come up again. Jess will do both walking and bike riding for exercise. Brisk walking burns about 345 calories per hour, and biking at a moderate pace burns about 690 calories per hour. Write a system of linear inequalities that describes Jess's exercise goals. Well, the first thing we're going to need here are variables. We're going to try and figure out what these variables are. I'm going to use W for walking and B for biking. I think that's pretty straightforward. So with my two variables, what I've got to do is combine them and figure out how they fit with the constraints I've been given. Okay, so we need to know that Jess would like to burn at least 2,000 calories. That means that the amount that she's going to burn has to be greater than 2,000. And what we're going to do is take the number of hours she spends walking, that's W, and the number of hours she spends biking, but we have to figure out how many calories she's burning, because this number is in calories. So just looking at a problem situation, she will burn 345 calories when she walks. Please notice that this right here isn't the number of hours spent walking, and we're going to multiply that by 345 calories. That means that if she walks 1 hour, she'll burn 345 calories. If she walks 2 hours, she'll burn 690. If she walks 3 hours, etc. That's what the multiplication here is for. Notice this coefficient is the same as this part of the sentence. So the other coefficient is for biking. 690 calories per hour for each hour spent bicycling. So here we have one linear inequality in standard form. The other one is the one that confuses people because there are no coefficients on these. What we're doing is we got to realize what our variables actually stand for. This right here, W, that's the number of hours she spends walking, plus B, the number of hours she spends bicycling. That has to be less than or equal to, that's what at most means, 5. Jess wants to spend 5 hours a week. So here are two linear inequalities in standard form that show the constraints on Jess's exercise program. The next step after this would be to graph them and such, but that's on a different night's homework. For today, we're just making the equations. Here's a more complicated situation. Suppose that the manager of an electronics company must plan for and supervise production of two video game systems, the basic, CP1, and the advanced, CP2. Assume that demand for both games is high, So the company will be able to sell whatever is produced. We don't have to worry about will there be leftovers or anything like that. The production scheduling at the electronics plant requires the plant manager to find a combination of CP1 and CP2 models that will give the greatest profit. That's what we're trying to do, is maximize the profit. But there are some constraints, also known as limits, on the choice. We can't make an infinite number of game consoles. There simply aren't enough hours or raw materials. So we have to limit it somehow. For each of the 3 parts below, please write a linear inequality in standard form, just like the last problem. What variables will you use, and what does each stand for? You got to figure that part out first. So, here we go. Each day, the plant has capacity for, at most, 240 hours of assembly labor, with each CP1 requiring 0.6 hours and each CP2 requiring 0.3 hours. So all the information that we need is here. Let's work backwards a little bit. We know that we can do at most 240 hours, so the number of hours has to be less than or equal to 240. But wait, I said we needed variables. I guess I'm going to, for the CP1, I'm going to use, what letter should I use? I'm just going to use X's and Y's. Good old-fashioned X's and Y's. X is the CP1, and Y is the CP2. So with our constraint here, we have to have at most 240 hours. That means whatever we come up with, whatever combination of X's and Y's, it has to be less than or equal to 240. So we're going to have the number of hours assembling the CP1s. Well, how much does each one take? 0.6. So 0.6 times X plus 0.3 times Y, where Y is the number of CP2 consoles and 0.3 is the number of hours that it takes to assemble one. So we take the number of CP1s times the time it takes to make each one, and the number of CP2s times the number of hours that it takes to make each one. And when we add those two quantities together, we have to come up with a number that's less than 240. Sorry, less than or equal to. Similarly, and we're still going to use X for CP1 and Y for CP2, we can have at most 160 hours of testing for these. You know, they put them on a bench and plug them in and make sure that the thing is going to work right when they ship it to you. So here we've got another constraint. This is going to be 0.2 hours for each CP1. I'm getting that right from this text right here. CP1 requires 0.2 hours plus 0.4 times the CP2 numbers. How many CP2s we have? Sorry, my 4 looks a little bit like my Y, but that's a 0.4 Y. That has to be less than or equal to 160. Now we have two constraints, one on the assembly time and one on the testing time. This is the last one. There's a third constraint here, and again, this is the one that messes people up because there are no coefficients to find. There aren't as many numbers in this sentence as there were in the previous ones. So you've got to kind of understand what's going on and what your variables mean instead of just plugging and chugging in some kind of formula or format that you don't really understand. Here, we're still going to have the number of CP1s and the number of CP2s, but here we just add them together because this problem, instead of talking about time, is talking about the actual numbers of video games. So here, they can pack and ship at most, that's less than or equal to again, at most 500 video games in a day. So even if they have extra hours for assembly or extra hours for testing, they can only do a maximum of 500 per day. So we've made our three equations for this. We've got a system of linear inequalities now. You should have these done on your worksheet to be turned in. And till next time, anyway, thank you very much.